Huh, that contest for math videos is happening again, but I've never made one before. I guess that's the whole point, but what format should the video be? Oh, I know. I'll record myself writing on the whiteboard and talking about it as I go. According to all known laws of aviation. Just gonna label the forces on this wing here. The audio isn't great, and I don't have a lapel mic. There are awkward pauses too, since I have to finish drawing before moving on. Maybe I can record the audio and video separately. The video is longer, so I'll just speed it up to match the audio. According to all known laws of aviation, there is no way a bee should be able to fly. Or is there? Today, we're going to be taking a first course in microfluidics. That's better, but the timing of the board doesn't match the script. Some things take longer to write than to explain, or vice versa, so the transitions between topics don't line up. Okay, so I'll cut the video and audio into clips where each one covers a single idea. Then I'll change the speed of each video clip to match the audio and splice them all back together. So at every point in the audio, I need to figure out what part of the video should be showing at the same time. In other words, I need a function f that inputs a time x between the beginning and the end of the audio and outputs a time y during the video, which tells me what frame should be on the screen. All of the things I've tried so far can be expressed as functions that way. So let's graph them. I'll mark the boundaries between clips as x1 through xn on the audio side and y1 through yn on the video. So in this case, n equals 8. The points xi, yi represent alignment. The transition between clips in the audio happens at the same time as in the video. So we want f of xi to equal yi for all I from 1 to n. This general type of problem, finding a function which passes through a given set of points, is known as interpolation. The first attempt, which just scaled the whole video, is a straight line connecting beginning to end. However, this function misses the other points of alignment. On the other hand, when each video clip is scaled independently, the graph connects the dots with straight line segments. This is linear interpolation, and the speed at any given point is just the slope of the line segment. And herein lies the problem. When transitioning between segments, the slope suddenly changes, which is visible in the graph as a sharp corner and in the video as a change in speed. The graph of the function we're looking for should have no such corners, making it some kind of round curve. To find the speed in this case, we use the derivative of f, which provides the slope of a tangent line to the curve. We want the derivative to be continuous, i.e. small changes in x should not cause drastic changes in f prime. Functions with this property are called continuously differentiable, or C1 for short. So f should be C1 in addition to interpolating between the points. Fortunately, this constraint comes up in other problems quite frequently, from image scaling to animation, and many of them have settled on the same solution, cubic interpolation. But that'll have to wait for another time.